you're having an amazing day, we are going to have a look at problem number 5 from 2019 A-Level Combined Mathematics, the first paper. This one is about a limit. We have to show that the limit given in this is equal to 1 over 2 pi. Let's see how this is done. One thing about A-Level you have to keep in mind when you do problems like this or any other problem in the exam. A-level problems can be done in different ways, but you have to keep in mind that whenever you do a problem that you stay within the context given in the syllabus for A-levels. For example, if you look at this limit problem, one can do this problem using something called the L'Hopital's rule, which is not included in the syllabus that uses derivatives to get the limit done. But this one can be done in a different way. So we are going to look at that additional method. The method I just mentioned is the shortest way, the most suitable way. So if you search internet, you will find that method used for problems like this. But when it is not considered in the syllabus, you should not do that because those might not earn the points even though those methods are right. That is the way usually A-level is graded. So we are going to look at this problem. Now this one is asking you to find the limit when x goes to 3 of this complicated looking expression. So we have sine pi times x minus 3 to divide that expression, and we have to show that this is equal to 1 over 2 pi. Now the way I'm going to approach this is, because of the root, I'm going to approach this in this way. I'm going to multiply this numerator with its conjugate. Now if you have root x minus 2 minus 1, the conjugate would be root x minus 2 plus 1. So if I multiply the top with x minus 2 plus 1, then you have to do the same to the denominator, which is x minus 2 plus 1 again. Then you do the little simplification, which gives you the numerator to be x minus 2 minus 1, and the denominator, I'm going to just write this here and the denominator here separately. And then we get to break the limit in this form, because this is a product, I can give the limit to each of them separately. And now you see this part, when x goes to 3, when this is 3, you get root 1 plus 1, which is 2. So this limit is actually equal to 1/2. Then we have to work on this one. So how do you work on this one is depends on the sine formula given. We know something about sine involved limits. If we have, say, limit n goes to 0 of sine of n divided by n, then as long as you have this n which is going to 0 divided by n again, this whole thing is equal to 1. So we are going to use this identity to answer this question, but I don't have that exact form I want, but I have the sign. So my idea is to divide this sine pi x minus 3 by the pi x minus 3. The reason I'm doing that, because when x goes to 3, the x minus 3 goes to 0. So we have the property that we are looking for, and that we have x minus 3 up here. So let me show you how we can change this to get that form in. First of all, let's look at this limit, which is 1/2, and put it in the front. Carefully look at this part of the limit. Now, how do I get this expression to look like that? It's going to look at this way. Now I have limit x going to 3. Now here in the x minus 3 on the numerator, instead of looking at it as multiplying the numerator by x minus 3, I'm going to look at it this way. I'm going to leave 1 over sine pi times x minus 3, and then multiplication on the numerator by x minus 3 is same as division by 1 over x minus 3. So when I do that, the result is gonna look like, if I just take some, make some space here, and then limit x goes to 3, 1 over sine pi x minus 3 it simplifies to give me a division by x minus 3. Now I want to have the exact same thing here that appears in here, which is like n is in sine, then this should be n also, but this one has a pi, so I need a pi, and that's a constant. So what we can do, I'm going to force that in, and then at the same time multiply with 1 over pi to cancel it out, so that I have the form that I want. Now when x goes to 3, we know this term goes to 0 and also that goes to 0, giving us the exact same situation that is happening here. These guys are going to 0, so the limit equals 1. Then this part should be limit equal to 1, leaving us with only, if this whole thing is 1 divided by 1, it leaves only 1/2 times 1 over pi, giving us the result 1 over 2 pi as the limit, and that is because this is equal to 1 once you take the limit. This is a very short problem. Answer is very short, a quick one. As long as you understand the steps that we took, you should be good with a problem like this. And we are going to do more problems of this form, and if you like to look at the singular version of this one, there will be a video of the same problem, and we will see you with more problems in the future.